Hello and welcome to today's seminar in the Smart Mobility Connection series. My name is Carly Benhar-Kukula and I'm the 2019 Women in Transportation Fellow. The Smart Mobility Connection series is sponsored by the Traffic 21 Institute and the Mobility 21 University Transportation Center as an opportunity for faculty to showcase their current transportation projects. It is also an opportunity for students, fellow faculty, deployment partners, and the broader community to engage and network with researchers, highlight opportunities for involvement, and foster future interdisciplinary collaboration. Please note this session is being recorded and all participants' microphones are muted. To ask a question, please send a message through the chat box. You do not need to wait until the end of the presentation to send your questions. Now, I would like to introduce today's speakers. Maxine Eskenazi is head of the Dialogue Research Center at Carnegie Mellon and on the faculty of the Language Technologies Institute in the School of Computer Science. Her interests lie in dialogue systems and smart agents. She has published over 170 refereed publications and 2 books and has an H-index of 45. Dr. Eskenazi has created dialogue systems such as the Let's Go bus information system that have been widely used. Alan W. Black is a professor at the Language Technologies Institute in the School of Computer Science at Carnegie Mellon University. His 40-year research career looks at practical applications of research techniques in speech and NLP. He was the lead developer of the open source festival speech synthesis system, which pioneered a number of speech synthesis technologies, and the FestBox voice building software suite has been used to build speech synthesizers in over 750 different languages. Yulan Feng is currently a Master of Language Technology student at CMU, co-supervised by Dr. Alan Black and Dr. Maxine Eskenazi. She is a research assistant in DIAL-RC with research interests in dialogue systems and natural language processing. Please help me welcome Dr. Eskenazi, Dr. Black, and Yulan Feng as they tell us about their University Transportation Center project, GetGoing and Better Mobility for All.
Thank you. So I'm going to share my screen and okay, can you all see my screen? I'm hoping that's yes, because I can't see you. Okay, so let's get going. This is GetGoing and Better Mobility for All. I'm Maxine Eskenazi, and I will be presenting along with Alan Black and Yulan Feng. So some things you take for granted when you go somewhere, that you can easily get directions on the web, that you can understand and remember those directions, or that if you have to climb stairs or a steep hill, that's fine. But many people cannot take these things for granted.
Maxine, we're just seeing the first page of the slides.
Okay.
Title 1.
Let me see if, can you see now?
Yes.
Okay, so yeah, I've had problems with this before. I'm sorry about this on the side, but we're going to have that on the side. Okay, so some people can't take these simple things for granted. Easily getting directions on the web. Some folks have no internet connection or smartphone access. Understanding and remembering those directions. Some seniors need some time to remember things. And climbing stairs or a steep hill, I mean, this is Pittsburgh. For some folks who have mobility issues, that does matter. So what are we going to do in this talk? I'm going to talk about the overall goal of GetGoing, the 3 areas that are within the GetGoing project, and how the system works. Alan is going to talk about the challenges in responding by speech, and Yulan is going to talk about technical details of each mode and demo the system. So the overall goal of GetGoing. GetGoing helps people with the issues I mentioned to get places that they need to go or just where they want to go. GetGoing must be universally accessible, which implies phone-based. GetGoing must be easy to understand. GetGoing must give information that is easy to retain, and it must give information that is tailored to the type of need for seniors, for mobility issues that a group of individuals may have. So what makes GetGoing special? Well, I've said twice, phone-based. It needs to be phone-based because some people do not have a computer or smartphone, but can certainly in some way access a phone. And to make it more affordable, we always use a local area code. Local walking, driving, and public transportation information that we give. The agent's speech is adapted for seniors. We speak in a different way from, for example, Google or Alexa. We translate web-based information into the very different delivery format of oral speech on the phone. For example, when you look at the web, you have images that you can easily use. When you speak out, you don't have those images, and you have to translate the information in the images into the speech that your system is speaking out. So there are 3 areas of focus in GetGoing. The first one is aiding seniors, and that's in getting around Western Pennsylvania. We mostly take the information, the data that we need from Google, and this has been deployed. It has a phone number and it works, and you can call it, and it got deployed just before the beginning of the pandemic. And so seniors are not really moving around a lot right now. So we haven't been able to test it, but we hope to test it when seniors are able to move around again. Aiding mobility impaired folks. So this is getting around downtown Pittsburgh and Oakland, and our partner, Pathview, is a company that has mapped out all of the obstructions that may be encountered by somebody who, let's say, is wheelchair bound in downtown Pittsburgh and in most of Oakland. They can tell you where there are difficult routes, and they can give you alternate routes that you can take if there's something that would be just too impossible to use. There's an early version of the system that exists now, but we have not deployed it yet, and we and Pathview also still need to do more work on it to get it to the point of deployment. And the third area of focus for GetGoing is aiding folks to get around in places that Google does not cover, like hospitals. Our partner here is UPMC, and we're working on getting around the Presbyterian Hospital campus. That's an interesting thing because Presbyterian Hospital is composed of several buildings. And again, this is Pittsburgh, and so there are hills and things are at different levels, and you have to figure out how to get into the hospital. It is intended to be deployed in beta version by the summer of 2021. And then, because unfortunately, despite the pandemic, people still need to get into hospitals, tested by the end of 2021. So it will get you to doctor's offices and outpatient clinics and other parts of the hospital. So let's go under the hood and take a look at how GetGoing works. So here you can see this microphone should look like a little telephone, and you call up GetGoing, and it goes through the telephone connection, and the speech signal goes to automatic speech recognition. Speech recognition takes the speech signal and transforms it into a string of words. It doesn't interpret the words, but it says, these are the words that I think were said in this order. That hands it over to natural language understanding. A natural language understanding tries to figure out what the user said. It does that by doing 2 things. One is determining what the intent was, and the other is what the slots were. So the intent is, what does this person want to do? Do they want to get directions? Do they want to get a bus time? What exactly do they want? And the other part is, what are the specifics? So let's say that the person calling says, I want to take a bus to go from Forbes and Morewood to the airport. And so natural language understanding would say, they're looking to get bus times, and the departure is Forbes and Morewood, and the arrival is the airport. and it's going to send that information to the dialogue manager. Now, the dialogue manager is the brains of the operation and decides what needs to be done and how. So the dialogue manager looks at it and says, well, gee, this is interesting. Should I do a database lookup? I know where they're leaving from. I know where they want to go, but I don't know what time. So I can't do a database lookup. So I'm going to tell the natural language generation, which puts together what the system is supposed to say to the user, to ask the user to tell me what time they want to leave. And natural language generation puts together a sentence, and the text-to-speech makes it sound correct for the user so the user can understand it, puts it into a speech signal and sends it out here to the user. So the user may say, oh, I want the next bus. And that will go through again. Natural language understanding will say, the time slot is filled by now, and we'll tell the dialogue manager. And the dialogue manager will say, I need 3 slots to do my database lookup. I need to know where they're leaving from, where they're going to, and what time. I have everything I need, and it does the database lookup and finds out the scheduling information, sends that to natural language generation, and natural language generation and text-to-speech give the user something like, the next 21X leaving from the airport will depart Forbes and Moorwood at 10:10 a.m. So some details that the system needs to know. The system needs to know which GetGoing system, which mode you want, whether it's seniors, mobility challenged, or hospital directions. And so in order to keep the dialogues more simple, for now, each of these modes has its own phone number. And for the first 2, seniors and mobility challenge, we want to know what type of transport. We may want to know that for the hospital directions as well. We're putting that together right now. So bus, car, walking, or using wheelchair only. And then we want to know details about the trip. We want to know, as you've seen, the point of departure, the destination, and the time. In the case of the hospitals, it may not be, I want to leave at such and such a time, but I have an appointment at 11 a.m. What can I do to get there by that time? So we also deal with incomplete information. Now, even when you use Google, getting around with Google can be difficult, as most of you probably know. It has its limits. So what happens when you have an appointment somewhere on the Presbyterian Hospital campus? You can find the bus that takes you from, let's say, Forbes and Murray to a street corner near the hospital. But then I see an entry over here up this street to my left, and I see another entry right down the street in front of me. So which one should I use? And how can I get to that entry safely? What if there's some construction or a broken sidewalk that I should know about? And is there a short way if I'm in a hurry and I am not mobility challenged to get there? And then something that Google can't do at all. Well, what do I do once I'm inside the building? So that, for example, in Oakland, on Presby, there is a senior geriatric center that is up in the back. It's not on Fifth, it's way up on the hill, okay? And Google will give you directions to get there, which is walking up the hill. But a better direction is go into the building that's on Fifth Avenue and take the elevator up to the 4th floor and walk across. So these are the things that we are trying to offer and aid people to get places beyond what Google can give them. Okay, next up, Alan Black is going to talk about GetGoing and speech synthesis.
Okay, thank you. Just let me bring the slides up. So can everybody see the slides and the movement?
Yes.
Good, thank you. So what I'm going to talk about in the next few slides is about how we generate the actual speech, the language in the speech that we're actually talking about. So I'm going to talk about speech synthesis themselves, that technology. I'm going to talk about choosing what to say, the choice of the words, I'm going to remind us that we're using dialogue, so it's not a one-way communication. We're actually got this communication between the machine and the particular user that we're dealing with. I'm going to talk about grounding in a technical sense to make sure that both sides know they're talking about the same thing. And then I'm also going to talk about where do we get these directions, particularly the directions inside buildings. Google is very good at giving us street level directions. They already have a system to do that, but how do we get the directions about go along to the elevator, go up to the 4th floor, turn left, go past the cafeteria, and then you'll find the doctor's office on the left. How do we get that information and be able to encode it such that we can give that information out to the users? Google, or whoever, we're actually using Google text-to-speech. It's pretty high quality. It would be hard for us to be able to compete with that technology within the university. We do research in this area, but being able to do this, well, we're primarily using English, is something that's not what we're going to do. So we're not really going to focus on how speech is actually made, how speech is focused when it's spoken. So when you speak, you decide what the important words are, and you put more emphasis on the words that are more important, words that you've mentioned before. You reduce, you do less articulation in words that you've mentioned before, but we're just going to depend on the text-to-speech engine to be able to do that. But there's still a substantial amount of things that we can do when we're getting things to be spoken by a standard text-to-speech engine that allow us to be able to control the understandability of the speech that's coming out of the system. And remember, we're dealing with seniors who may have not as good hearing, they may not be as cognitively alert, they may not be as used to listening to machines as what perhaps younger people are doing. So there's lots of things that we can do. Instead of just saying go up to the 3rd floor, it might be better to say you will need to go up to the 3rd floor. And that introduction part helps people focus on the new information that's going to come afterwards. And we've done experiments of trying to find the best ways to be able to do that. We also want to care about how we present the data. We don't just want to say GHC or some abbreviation that may not be familiar. We'd like to be able to give the full information, Get-Tillman Center, if that's what we're actually trying to do. So we want to make sure that we have expanded these things or chosen the most familiar way of being able to change that. There are also things to do with explicit pauses that we can do. If you want to be able to give an important piece of information, it's often worthwhile focusing just before it so that you can actually get people to know that they're going to hear a key piece of information. Even though that's slightly an unusual place to be able to put breaks, we don't do that in normal conversation. So you'd say something like the 4th floor rather than just saying 4th floor. We also want to make sure that we're choosing the way and how we actually present this information. Directions are quite hard, they're very information full, and it would be a good idea to be able to give it in chunks that are actually a reasonable length, in fact maybe even the same length all the way through, and make it easy for people to remember them rather than just give a big long prose of how to be able to get somewhere. It's also a good idea to have the same sort of shape for these chunks. And by shape, I mean sort of the underlying template. So saying turn left, turn right, turn slight left, rather than turn left, go right, then down left. It will be easier to remember the first one than the second. Okay, intro and content. It's a good idea that you do this introduction and say you will need to, or in order to get to, so that you've got some introduction, and then you give the key piece of information, which is probably the thing that's being written down, and you want to give sufficient time to be able to allow people to be able to write down and confirm that you're actually doing that writing. Okay. Remember, we're also using dialogue. We're not just doing a one-way delivery. There is no visual component on what we're doing. We're talking about the plain old telephone system, so it really is all to do with speech. And we want to make sure that we make use of that telephone channel. And of course, we can do confirmation. We can check that the person's getting the right information. We can check that the person knows that they are having to write down information of what the key pieces of information is, and we can also confirm during the conversation that's actually happening. We might also get explicit questions back from the user who may ask something about, can you say that again? Or did you say go to the 3rd floor? And the system should be able to reply to that and say, no, we said the 4th floor. Okay. And also we'd like to be able to get summarization to make sure that the person really got it, maybe at the end give a summarization. So there are 4 steps, and explain what the 4 steps are, maybe without all the detail, but enough to confirm that the person has actually got that information using dialogue rather than just simply a one-way generation. Let's talk about grounding. Grounding is a technical sense. When 2 people are talking, they have to have a common ground for the things that they're actually talking about. And we do this sometimes explicitly, but often implicitly in speech. So we can say things like, do you know the main entrance on Forbes? And people can say yes or no. And if they do, you can talk about the main entrance now. If they don't, you maybe want to be a little bit more explicit. Well, it's on the north side of Forbes and it's just next to the bus stop, past the whatever side street is actually there. So you can choose the right terms that actually match what the user is saying. And you should listen to what the user is actually saying and try to use the same terms. This is actually called lexical entrainment. And there was quite a substantial part of research that Maxine did a number of years ago under an NSF grant. And it's a good idea to have these common terms when you're actually talking with someone, because they'll remember things correctly. And if the machine is always changing the term to something else, the user often gets confused about, wait, are you talking about a different set of stairs? Or are you talking about the same set of stairs that I was talking about? So you'd like to be able to use these same terms, use standard terms, and sometimes the related standard terms that you want to make sure you want to have, you know, arrival and departure rather than enter and exit or something like that. You want to make sure that there's related forms of that. And the last thing I want to touch on, and Yulan will talk about this later and give you some examples. How do we get the information about how to travel within a building? Google doesn't talk about that. It talks about street to street information, address to address, but once you get inside, you have to know what to do. And there's some standardized ways of doing this. Can we take human descriptions from somebody who would normally be at the front desk? They're going to explain how to get to Dr. Smith's office, and they might say, well, you go over there, or you go over to the front entrance and go in the elevator and go up to the 6th floor. And can we take that information and join it together from multiple people and find a standardized way of describing things and maybe build an actual graph out of it so that we can give arbitrary descriptions within the building without us having to map it all. And so that's something that we'd like to be able to do. And Yulan will actually talk about this later in the research that we've been doing to try and collect that information. I'm now going to pass on to Yulan to talk about the rest of the details.
Okay, thank you, Ellen and Maxine, for their parts describing the higher level challenges and also the motivation of the overall system. Next, I'll be talking about more details of the 3 different modes that Maxine introduced. First, when we initially designed GetGoing for seniors, we were motivated by the following facts. First is that only 53% of seniors above 65 years old have smartphones, but most of them do have access to non-smartphones. Secondly, as we age, literatures show that we tend to struggle more with synthesized speech delivered at faster rates, and we can be more easily distracted when multitask. However, what's encouraging is that HCI experiments show that seniors with little or no previous experience using computers also found conversational agents easy to interact with. And thus, we designed the following features tailored to the special needs of seniors. First is confirmation of understanding. We confirm that the user understands the system output and has sufficient time to write things down if they desire. before the system proceeds to the next step. This addresses the concern that older users be able to comprehend and retain instructions. Second is barging feature. This allows users to interrupt the system at any time. This change shifts control of the dialogue system towards the users, allowing them to correct the system mistakes without having to wait for the system turn to finish. And it avoids the user's turn getting out of sync with the system. By flexible dialogue manager, we refer to a flexible and natural dialogue manager in the order of turns. It allows users to easily correct the system, provide information out of turn, or fill multiple slots at once. Slower synthesized speech is not only slow down the overall rate of the speech, but also inserting pauses prior to synthesizing the speech signals. It helps to make utterances more understandable for users who process speech more slowly. And as Maxine mentioned, we designed the system to be telephone connected. This change, as compared to the graphical user interface, reduces the entry barrier for the senior users who may not own a smartphone who may not be comfortable using one. Finally is the attention-grabbing prefix. We insert an attention-grabbing prefix such as the first step is what you need to do next is, or the final step is prior to providing important information, and thus allow users to switch attention and tune out distraction and focus on the system output. Next, I'll show a demo video of the system contrasting the regular delivery versus senior delivery of the system.
Welcome to CMU GetGoing. How would you like to travel today? I can give you public transit directions or driving directions.
Public transit.
Great. I will provide you with directions to your destination by public transit. Where do you want to go? For example, you can say, I'm going to the airport.
Children's Hospital.
Okay, going to UPMC Children's Hospital of Pittsburgh. Where are you leaving from?
CMU.
Okay, leaving from Carnegie Mellon University. When do you want to travel?
Now.
Okay, traveling at 4:18 p.m. Hold on. I'll look up the directions. Would you like me to pause after every step to give you time to write things down?
Yes, please.
Okay, great. Feel free to ask me to repeat a step if you didn't catch it the first time. There are 4 available routes. To hear a different route, say alternate route. The amount of time your trip will take is approximately 21 minutes, and you will take 1 bus. Walk for about 7 minutes to Craig Street at Park Plaza. Take the 93 to Main Street at Penn Avenue. The first thing that you want to do is to walk for about 7 minutes to Craig Street at Park Plaza. Shall I proceed?
Continue.
Next, you should take the 54 to Main Street at Penn Avenue.
So this demo shows that with the though these 2 deliveries of the system provide the same instructions and the same information, the senior mode leaves enough time for the user to take notes or just find paper and pen to take the notes, and thus leaving the user more useful information for further route planning.
Welcome.
Second, to further customize our system for those mobility impaired, we collaborated with Pathview, a local startup focusing on pedestrian accessibility. With this collaboration, we aim to let users navigate sidewalks faster and safer without barriers by providing more detailed walking directions. We also consider various accessibility modes depending on user needs. This includes low vision people, wheelchair users, and also cane users. Because the original pedestrian network was designed for a graphical user interface, we made a few changes to incorporate them into our dialogue system. First is to use natural language generation techniques to make the instructions understandable over the phone. We also combined information including road crossing and intersection into the delivery. And we converted addresses to and from geographical coordinates and deal with abbreviation and acronym so that the system in our database lookup can correctly locate the address while users over the phone can understand what the address are referring to. We thus designed a system that can be used over the phone by users with various mobility issues. It is now more accessible for visually impaired users, and other users can focus on their wheelchair, scooter, or walker while getting navigation information. Here is a demo of the mobility mode system as compared to the previous senior mode.
Welcome to CMU GetGoing. How would you like to travel today? I can give you public transit directions or walking directions.
Public transit.
Great. I will provide you with directions to your destination by public transit. Where are you going?
PPG Paints Arena.
Okay, going to PPG Paints Arena. Where do you want to leave from?
CMU.
Okay, leaving from Carnegie Mellon University. When do you want to travel?
At 2 p.m.
Okay, traveling at 2 p.m. Would you like me to pause after every step to give you time to write things down?
Yes, please.
Okay, great. Feel free to ask me to repeat a step if you didn't catch it the first time. Just a minute. Let me look up the directions. You are now hearing the default Google directions. To hear a route in mobility mode, please say alternate route. The amount of time your trip will take is approximately 18 minutes, and you will take one bus. Let me know when you are ready for the next step.
Yes, next step.
The first thing that you want to do is to walk for about 3 minutes to Forbes Avenue at Craig Street. Shall I proceed?
Yeah, continue.
Next, you should take the 61C to 5th Avenue, Muddy Street. It will depart at 2:04 p.m. Let me know when you are ready for the next step.
Next step.
The final step is to walk for about 1 minute to 1001 5th Avenue. Please tell me when it's okay to continue.
Alternate route.
You are now hearing the mobility wheelchair mode. The amount of time your trip will take is approximately 18 minutes, and you will take one bus. Shall I proceed?
Continue.
The first thing that you want to do is to start at Carnegie Mellon University. Go west on Forbes Avenue towards South Craig Street, and then cross the street at South Craig Street. Shall I proceed?
Next step.
Next, you should turn right on South Craig Street. Shall I proceed?
Continue.
Next, you should turn right on Forbes Avenue and finish at Forbes Avenue at Craig Street on the right. Shall I proceed?
Yes, continue.
Next, you should take the 61C to 5th Avenue, Muddy Street. It will depart at 2:04 p.m. Please tell me when it's okay to continue.
Continue.
Next, You should start at 5th of McGee Street, go west on 5th Avenue toward McGee Street, and then cross the street at McGee Street. Please tell me when it's okay to continue.
Next step.
The final step is to continue on 5th Avenue and finish at PPG Paint Salon on the right.
So in the previous example, the user needs to go from CMU to Pittsburgh Paints Arena, and thus the first step is to go to the closest bus stop. So if you're a local Pittsburgher or a senior student at CMU, by saying walk for about 5 minutes to South Craig Street, you'll know how to walk there. However, what if you are a visitor to Pittsburgh or a freshman here, without a physical map or visual demonstration of the route on a graphical user interface, you have no idea how you can get there. And thus, with past views data, we can demonstrate to the user how to get there exactly. So here is a picture at the intersection of Morewood and Forbes. That is the main entrance of CMU. So in order to go to the South Craig Street, at this entrance, you have two options. The first is to cross the street on Morewood, and the second is to go to the South Craig Street first and then cross the street there. So in this example, there is construction going on across the street, and with the crowdsourced data, the system is aware of this construction and thus lets the user not cross the street here.
Go west on Forbes Avenue towards South Craig Street.
So it chooses the alternative route of going west first. When we walk to the South Craig Street, it is now safe to cross the street.
And then cross the street on South Craig Street.
And then after crossing the street, you need to find the bus stop.
Next, you should turn right on Forbes Avenue.
And then you know the bus stop is right here. And so with pass view and the mobility mode, we customize the walking parts of the system, but the public transit or the driving directions part, we still use Google's data, so that is more complete. So how is the wheelchair mode designed? There are 4 safety factors on a scale of 1 referring to very comfortable to 4 completely comfortable that defines a mobility mode. So for the wheelchair mode, for example, it has a navigating tripping hazard of 3, a running slope factor of 2, cross slope of 2, and sidewalk roughness of 2. So for the other modes, these numbers will change, and for some of the routes that have different alternative routes, by selecting the right mode, the system will provide different instructions. Next, we'll jump to our design for hospitals. So our motivation is that Google information sometimes is not enough. When we need to know which door to use to enter a building, given where you're going, and how to get around when there are multiple entries and exits at different levels. Pittsburgh in this case is a very good example because it is hilly, and UPMC Presby campus, for example, is built on a steeply sloped area. And for CMU campus, one outside entrance on 5th floor in our building at CMU is 2 floors above another outside entrance on the other side of the building. And there are also stairs and elevators and also work being done. And then some of the work also needs to be done on the street or sidewalks. So here is a concrete example that Maxine has briefly mentioned. That is to walk from a bus stop to the Benedum Geriatric Center in UPMC Montefiore. If you ask the Google, actually you can check that with your Google Maps app or the website right now. So when you ask for this direction, Google provides you the following suggestion of walking from about 8 minutes to 4 Fifth Avenue. There are two problems here. First is that the address is wrong. The Benedum Geriatric Center is for sure not 4 Fifth Avenue because that will be totally another place. And then if you're using an app, you may not notice this problem because the ping here will locate the right location of the center. But if we need to deliver this over the phone, this will be problematic. And the second problem is that this instruction involves walking for 108 vertical feet of climbing. So the hill that you need to climb is also very steep. And thus for those with a wheelchair or those mobility impaired, it will be very hard for them to walk up this hill. And even for young people in winter time, when there are a lot of snow, it will also be very hard. And the optimal direction in this case actually is to walk for about 1 minute to 3459 Fifth Avenue. That is the main entrance of UPMC Montefiore. And then you can take the elevator to the 4th floor from the lobby. So how do we get this information? We get this optimal routes by interviewing receptionists at hospitals. So here is an example of going from the garage to the front desk of Montefiore. We interviewed 3 different receptionists, and we also get the direction in the official brochure. So here you can see that all of them provide a detailed and accurate direction. However, there's also some problem with human descriptions. First is that because humans provide descriptions based on mental map, their descriptions will vary from time to time and from person to person. And also they will contain a lot of colloquial or redundant information and making it harder to remember the exact routes. So our solution is use a unified description. So we use a pipeline in our system to automatically unify the human descriptions into a template-based systematic description, which matches the style of Google directions. First, this change makes the overall description of the system consistent and thus making the users less confused. Second, we did some experiments on Amazon Mechanical Turk, and the results are these kind of templated descriptions are easier for people to remember, especially when the descriptions involve more slots and also more information. Here is the end of our presentations. I would like to thank all of our developers, including Alan Black, Maxine, Eskenazi, me, and also another ML2 student, now a PhD student at LTI called Shakib. So if you're interested in our system, you can visit our website at dialrc.org and get going, or call out the system directly. So here is the end of the presentation.
Okay, the first question, how does this work for seniors or persons with disabilities who aren't able to speak? Does the system work with TTY systems for those who are hearing impaired?
It doesn't yet work for people who are unable to speak. We have a new project that it's not exactly for people who are unable to speak, but who have impaired speech. And we are going to start probably in the next few months collecting the speech of people who have difficulties in speaking and seeing how our systems can best reply to them. But no, right now we don't have anything for people who can't speak.
Okay, you mentioned testing the system post-pandemic. What are your plans for testing?
Well, let's start with what we're doing with the hospital. So in the hospital, what we're going to do is we're going to put flyers out at all the information desks and also in all of the doctors' suites, the suites of doctors' offices. And UPMC is going to put a reference to our system and an explanation of our system up on their website. In that way, people will know about the system and will be able to call it. And we're going to try to have as many people as possible calling the system. Post-pandemic, it's difficult to say exactly what we're going to have and when. And as somebody who just got her first dose of vaccination, I hear so many different things that are changing every week that I have no idea when that will be. If we would say getting back to normal, what we would like to do is we'd like to take GetGoing seniors and give it out to people at AARP. I see Jim is here, also to our fellow people in OSHR and in other places like senior centers, and give them the number and ask them to call it when they need to go somewhere. So we have partners who can help us to get the word out when people are starting to be mobile again. So Eric Sinagra is here, and I think he'd agree with me that we don't know exactly when we'll be ready to deploy for the mobility impaired people. We're still working on this, and it would probably be for people who are going somewhere in Oakland or downtown. And stay tuned for more information on that. And the hospitals, as I said, unfortunately, people always need to go to a hospital. So this summer, and it should be out this summer, and we'll hope to have results of the beta version in December.
Okay, I believe you answered some of this, how you plan to let seniors know that the application is there, and to which extent older adults believe this application is comfortable and convenient, if you have any data on that, and who has used this application, or if it has any foreign language version.
So far, we have demoed the application to AARP of Southwestern Pennsylvania at their chapter presidents' meetings, and they've given us feedback. Thanks to them, we now give people time to write things down, for example. They like it, they don't think it would be a problem, but we don't know how this will be when the people who really need it will get it, because the heads of the different groups at AARP are very mobile, they drive, and they don't necessarily need this help, they know where they're going. It's the same for OSHR. We believe that we need to get into senior centers to really see how people are accepting this. And so there'll be a lot of word of mouth, but especially senior centers. And I believe that when the heads of the different AARP chapters get the information out to their members, because when we were meeting with them, they would say, I know somebody who could use this right away. So when they get the information out to their members, then we'll have a better idea of how acceptable this is. But right now, we only have the feedback from the from working with AARP and what they think of it.
Okay, how does it handle uncertain destinations? For example, if someone would say, I'd like to go to the stadium, is there a process for disambiguation?
Yes, I can answer that part. Okay. So for speech recognition and also for the location configuration parts, both of the systems will return a confidence score, and we measure the confidence score there. If it's below a certain threshold, or if this address matches several possibilities. For example, if you say, I'd like to go to UPMC hospital, and there are a lot of hospitals. In that case, instead of the implicit confirmation of, okay, so you're going to this hospital, the system will explicitly confirm with you, are you referring to this children's hospital? And you say no. If you replied with a no, the system will say, like, then please give more details of your destination. Or if the system says, if the location that the system confirms with you matches your expectation, then by saying yes, the system will proceed like regularly.
How are users with visual impairments accommodated?
So the instructions for users with visual impairment is right now it's with cane and what issues they would encounter where it might not be easy to use their cane to figure out where to go. We would like to also include more detail, and this is what we need to work with PathView on. Eric can chime in if he wants to, where we would have to tell them maybe how many steps, or, oh, instead of saying, well, the entry to the building is straight ahead on your right, we might say something like the entry to the building is about 30 steps straight ahead to the right, or about 20 feet straight ahead to the right.
And also I'd like to add on that. So in the slides, I briefly mentioned the safety factors. So PathView has 4 different safety factors, and that's defined in different modes. So for low vision people or for like blind people, some of the factors will thus be different for those with needs of wheelchairs, and then different routes will be returned. So that's our consideration in terms of providing alternative routes. And then secondly, in terms of delivery, because our system does not use any graphical information, it's purely speech. So in that case, either low vision users, blind users won't have any problem using our system.
So Eric's saying that he can't unmute himself, but he agrees. And I think that if you could unmute Eric Sinagra, he would give you a little bit more information.
Hi, everyone. Thanks for asking the question. So yes, as Maxine mentioned, we're looking at better ways to add more details about the routes for people of all disabilities, including visual impairments. And so looking at things like, which side of the street to go down, what added details about intersection crossings, so which routes are most are the safest, maybe even limiting the number of intersection crossings. So adding detail to help the person with the visual impairment as best as they can understand what is the best route to go, limiting the barriers, and as much detail to know exactly what to do when possible.
So if I didn't say this, Eric Sinagra is the head of PathView. Thanks, Eric. Are there other questions?
Yes. In terms of real-world application, what entity would be most likely to host and maintain the system?
Probably Google. I mean, I could think of Amazon doing it, but it's not directly in their interests. I think we're closer to Google's interests.
Were there any cases where users had difficulty using this prompt system? And what is the system response if a user is having difficulty with the directions or prompts?
So we haven't been able to test it enough because it was ready just before the pandemic, but I can tell you some of the strategies that we use. There's a well-known strategy when people use automatic speech recognition and it doesn't work. So if you say, I want to leave from Forbes and Murray, and the system says, leaving from Wall Street, which it sometimes did in the past, then the user gets a little upset and they start to speak a little louder and they go, no, Forbes and Murray. And in that case, the speech recognition gets worse and worse because we don't understand shouted speech. Or they will say, no, Forbes and Murray, and we don't understand that either. So when we realize that we're repeating the same thing to the user and we're not getting the information we want, we change the subject. And so we'd say, for example, well, what neighborhood are you leaving from? And that enables the subject to bring their speech back to a normal type of speech where they're not shouting and they're not hyperarticulating, and it makes it easier for us to understand. In general, when that happens, we're able to get the right meaning from the user and continue the dialogue.
How hard would it be to provide directions along the way, for example, through the PathView app, when in mobility deployment mode as opposed to upfront in advance, or did you already do this?
No, we haven't done it and we're thinking about it. That's definitely something we'd like to do. So if you want to go somewhere and you have your bus directions and you get off the bus and now you want to know what to do, you should be able to use it right then when you get off the bus to know where to go. Yes.
And that is all of the questions we have.
So I'd like to thank everybody for coming and asking all these questions. If you have other ideas, or if you have contacts in senior centers or places where you know of people who can try out our system, we would be most happy to have those contacts from you. And thank you.
Thank you so much, Dr. Eskenazi, Dr. Black, and Yulan Feng. And to all of today's attendees, thank you for joining us. As I mentioned earlier, today's presentation will be posted on the Mobility 21 What's Happening page of the website, along with a link to the video of the session. This afternoon, you will be receiving an email asking you to take a short survey about today's SMC. Please take a few minutes to provide your feedback. For students who are interested in engaging in transportation topics, the Transportation Club on campus is a great way to plug into transportation topics with fellow transport nerds. Our next SMC will be on March 12th, 2021, and will feature Jeremy Michalik, who will present his project Uber and Lyft Implications, Vehicle Ownership, Transit, Electrification, Air Emissions, Traffic Externalities, and Equality. Watch for your invitation to join us closer to that date. Again, thanks for attending today, and please feel free to contact us with any questions.